Welcome everybody. Good afternoon. It's the last session of the day. We're going to talk about something called C++ in combination with Windows Phone applications. So that music that I played was for a purpose. It's a Dutch band. I'm from Holland. It's a band that was famous in the 70s. I'm an old speaker, an old presenter, and we're going to talk about old technology. So all fits together, maybe. Before we're going to start, I think it's a good time to, do a little demo. So let's just go ahead and let's see what C++ can mean for our Windows Phone application. So I'm going to start my first demo. And here's a very cool operating system, actually, what's going to come up. I don't know if you've seen this, like me, an old operating system. It's called MS-DOS. And at some time in the 90s, in the early 90s, late 80s, early 90s, there was this new, well, was it an operating system or was it an application? I'm not sure, but this is how you started it. And then you get Windows. Windows was an application on top of DOS. And inside Windows, we had a development environment. It's Visual C++ in version 1.52 here. And let me just start Visual Studio or Visual C++. And look how fast that is. That's amazing. If you've ever seen a development environment starting that fast, compare that to Visual Studio 2012, right? It's kind of unfair because the amount of functionality is a little bit less in this operating system, but okay. And at that time, 20 odd years ago or something, I wrote a little library with some math functionality. This library is very simple, actually. Unfortunately, I cannot really increase the font here because, at that time we didn't use beamers or something. We just, gathered around some piece of paper tape or something, right, to actually program our applications. But this is a little math library, and it's used to calculate a range of prime numbers. So I'm just going through a while loop. I'm going to determine whether or not something is a prime number, and that's it. Mission-critical business software, right? I mean, in an enterprise organization, this is typically the piece of software that you don't touch. Of course, maybe this is partly a joke, but think about it. I keep my samples very simple, but this could be a real scenario. In a financial organization, maybe some C++ code was written to do some, complex transactions. And of course, the people who developed that piece of software are all long gone from the organization. The software is still running, but everybody is like, hey, don't touch it, because if you touch it, it might break. And now, somebody comes and says like, hey, this cool piece of software that we use for our financial transactions or blah, blah, blah. Wouldn't it be great if we could run this on Windows Phone? Because this is basically the functionality, and this is how this application is working. So I can, actually just run the application. It's an MFC application, and after some time, you see a range of prime numbers. So it took the application a little bit to calculate those numbers, but hey, if this is important mission-critical information for my organization, then maybe I want to have it running on a Windows Phone as well. That in itself is the purpose of our, presentation today. So for the upcoming 70 minutes or so, I'm going to take time to take this application, bring it to Windows Phone, and in the meantime, while showing some examples, talk a little bit more about running native code on a Windows Phone and why you want to do that, maybe. So one of the real cool things of this Windows 3.11 was the following. If at some time I got tired of Windows, I could do something about it. Using Alt F4, I can first close down my application. Using Alt F4, I can close down Visual C++ 1.52. Using Alt F4, I hope, where's my Alt key? Using Alt F4, I can close down Windows, and it's not the end of the world. Closing down Windows in those days meant like, hey, I still have something else. I have DOS. These days, that's not possible. So that's, like progress, I guess. Now, if you close down Windows, it's kind of over, right? But then there was life, behind or after Windows. Let's just get rid of this. Let's go to the slide deck and let's talk about things that we are really here for, using C and C++ inside your Windows Phone application. So first, we're going to talk a little bit about why you want to use C++ inside a Windows Phone application. There are a couple of reasons, and I want to spend time to, cover all those reasons. I'm also going to talk about using and creating runtime components because they are an essential piece of the puzzle in order to make it possible to have native code running inside your Windows Phone application. At the end, which is probably not going to happen, that there is time for questions and answers because I know that everybody wants to win a phone, but I will be available, make sure to answer all your questions. If you like desperately need to go to the country drinks after this presentation, I can imagine that because after talking about C++, you definitely need a drink. But if that's the case, no problem. I'll be hanging around tomorrow and Friday at the booth, and I'm available to answer all your questions there as well. Now, this slide has been coming across for, like each and every Windows Phone presentation. So by now, if this is the first time you see this slide, you missed a lot of pretty good presentations already. If it's not the first time, then hey, I'm not going to spend too much time talking about it. Yes, Windows Phone is a great phone for business. Thanks to the fact that we make use of the Windows 8 runtime, we have, like a lot of cool features like security and stuff like that. Also, Windows Phone 8 is great to, like run software, but also run that software across multiple devices, Windows 8 devices, maybe even completely different devices. And that's where C and C++, native code for Windows Phone, perfectly fits in. Now, if you're going to develop for Windows Phone 8, you have a lot of different choices. If you start Visual Studio, the Express version, the free version, for instance, what you will get is a number of project wizards, a number of templates with which you can decide which type of application you want to develop. It can be a managed application using XAML in combination with C# or Visual Basic.NET. It can be a managed application using C# and Visual Basic.NET in combination with the XNA framework. And the reason why we still allow that is because you can also target Windows Phone 7.x applications using Visual Studio 2012. So that's for backward compatibility. You can also develop game-type applications using Direct 3D in combination with either XAML and C# or VB.NET, or native Direct 3D applications only. Those are exclusive for Windows Phone 8, so that doesn't run on Windows Phone 7.x. And they are typically, like targeted towards game developers. Not necessarily at this conference something we're going to spend a lot of time about, but I'm going to show something at least about it. And you can develop class libraries and components in managed and native code. So we're not going to cover the XNA framework. We're not going to talk about backward compatibility between Windows Phone 8 and Windows Phone 7.x. But our focus this afternoon is going to be on native class libraries in combination with a managed application written in C# and having a user interface developed in XAML or designed in XAML. So that's the stage for our like presentation this afternoon. Now the cool part of using C++ inside a Windows Phone 8 application is that we're using Visual Studio 2012. And it doesn't matter if you're using the free version, the Express Edition, or any other SKU of Visual Studio 2012. But we, as Windows 8 developers, are using exactly the same compilers as Windows 8 is using if you're developing a Windows 8 native application. And those compilers conform to the new C++ 11 features, which are, like a standard. And C++ in the back, like in the past, 20 years ago or something, has nothing in common basically with C++ today. Modern C++ is way more robust. The chances of, like dealing with pointers that are wrongly initialized or with memory that has been allocated but not freed up are just way smaller when you're using a modern version of C++. As a matter of fact, if you analyze what C++ can do today, what you will see is that some features that are available in C# were kind of borrowed by C++ and brought back into the C++ specifications. Now, this talk is not about all C++ features. It's more about getting C++ functionality running on Windows Phone. But hopefully next year at TechEd or at some other conference, we can spend some time also talking about C++, like really what kind of language features are we having. If you're developing or using native code on a Windows Phone, you have full debugging support, not just for managed code, but also for native code. So we also, like support completely setting breakpoints in native code, inspecting variables, skipping over statements, and all those good things that you would expect from a debugger. So let's just, do a little quick, fast demo about different project types inside Visual Studio for Windows Phone. So what I'm going to do is the following. I'm just going to start the Express edition of Visual Studio for Windows Phone. I'm going to create a new project. And what I can do is create a C# project. And here you have that large list of different templates that are available, including an HTML5 application, which basically is a browser that hosts HTML5 and JavaScript code. Of course, a C# application in combination with XAML. It can be a pivot or a panorama application, depending on what type of application you want to develop. But we also have this Visual C++ for Windows Phone. And what you will see here is that, hey, I can develop a Windows Phone Direct 3D application in combination with XAML, or a native-only Direct 3D application, or some unit test application, or a Windows Phone runtime component, or different libraries. So the first thing that you can see here, like, hey, there is only one executable type that you can develop in native code, and that's a Windows Phone Direct 3D application. Anything else, you can use native code, but you cannot develop an application entirely in native code. So you can use native code inside a library, for instance. But let me just create one of those applications right now, and I'm going to take this Windows Phone Direct 3D application. I'm just going to create one. Very easy stuff. I get a header file containing, like the declarations of all the methods that have been generated for me, and I get a C++ file with an implementation of all those methods. And if I'm scrolling down here, what you will see is what, should be familiar for people who are, used to C++, is an honest main entry point. This is the location where our application starts running. It has, like a modernized version of passing command line arguments. So instead of an argc with an array of argvs and stuff like that old C++ programmers are used to, I now get a nice array of command line options that are passed to my application. Another thing what I can show you is if we take a look at our project properties, what you will see is that, hey, if I take a look at my compiler, I have a lot of options for the compiler. I can specify if my code needs to be optimized. And that's typically something, once you develop an application, you try to optimize your code to get it running as fast as possible on a target device. I can do that. And what you also can see is like, hey, I am using a real C++ compiler. Look at that command line that is, like underwater being called to actually invoke the C++ compiler. For the linker, the story is kind of the same. I have a linker to link all my object modules that I compiled using the C++ compiler together to an executable or to a DLL or a lib file. I can specify additional library files that need to be part of my functionality. And again, if I take a look at the command line, you see a long list of options in order to get the linker running properly. This is already kind of proof that, hey, if I'm creating one of those direct 3D native applications, that is real native code. If you compare that to a C# managed application, what you will see is that there is some library that we're creating, and that library is called from some runtime environment. Well, here we are running bare metal on bare metal, which gives you a lot of power, a lot of performance, a lot of good things, but also a lot of responsibility, of course. Another way to look at this and showing that this is like real native code is if we take a look at our target. Right now, I'm going to target the emulator 720p. And if I'm doing that, then what I'm actually generating for my compiler is Win32 code. The reason for that is that the emulator, the Windows Phone emulator that ships with Visual Studio 2012, is an Hyper-V virtual machine. That Hyper-V virtual machine runs on Windows 8. My Windows 8 laptop has an x86 compatible processor, so I'm actually targeting Win32. I need to create x86 compatible machine code in order to execute native code inside the emulator. But if I change to a real device, what you will see now is that, hey, I'm going to target ARM code because our Windows phones are equipped with some sort of an ARM processor, a dual-core ARM processor type. So that's another, like kind of proof that we are dealing with native code here. I'm going to target this emulator, and if I'm running this application, well, there's nothing fancy about it, and probably everybody tried that, like just because you can. But what you will see is once the emulator is started, you see that it's taking some more time actually in order to compile. I need to compile a lot of header files, I need to do a lot of things because all my functionality was available as source code plus a number of libraries. If I'm developing or if I'm compiling a managed application, that's just going way faster because there's less to compile. And what you see here is, hey, I have this, like nice cube spinning around, an example of, like a great starting point for a game. But again, we're not going to talk about games, so I'm just going to terminate that. So this was just an overview of some different project types and a proof that this was real native code that was running here inside my Windows Phone emulator. So C++ in this year is completely different from C++ when Windows 3.11 was around. C++ right now is a modern programming language, and a lot of the features that C++ offers are familiar to C# developers. And like back in 2000 or something, when the .NET framework was kind of released, we had this transition, this move that, like everybody was excited about C#, and everybody kind of moved to, like developing .NET applications. Because .NET applications are typically platform independent. You still can see that today with a modern XAML application. I don't need to specify a target platform, what I did with native code. But I can just specify, like what kind of device I'm running on without having to know details of the processor underlying there, because there's a just-in-time compiler that takes care of compiling MSIL, intermediate language code, to native code. And the just-in-time compiler knows exactly on what type of a processor it's running. For C++, that's different. But if you look at Windows 8 and how Windows 8 is structured and how APIs are exposed inside Windows 8, that is through COM interfaces, the component object model interfaces. And those components, those binary components, are a perfect match for native code, for C++ code. That's the reason why C++ is becoming more and more important again from a Microsoft point of view. At the same time, if you're developing a Windows Phone application, I can imagine that you're not just only targeting Windows Phone, because there are some other phones around as well, like some more popular, some less popular. But there's, for instance, if you develop an application, probably customers demand also a version for that application on Android and on iPhone. And if you stick with all the, like programming environments for those different types of platforms, then the chances are kind of big that you're going to end up developing that same application 3 times or something. If there is a common language that you could use to at least have your functionality written in, then your life would be easier. Maybe you still have to worry about the user interface, but C++ is that common language that will execute on all those types of devices. So that's pretty cool, actually. Now, again, it's a modern version of C++ that we're using these days, C++ 11. For instance, in C# you have things like a var keyword with which the compiler determines what the type is of a variable. Well, in C++ we have the same thing right now because we have an auto keyword that does exactly the same. Lambda expressions are completely supported in C++, and also anonymous functions are supported. You can have enumerations that are strongly typed. In the past, they were just only unsigned integers, but if I want to have a range of enums right now in C++, I can do that. And with that, the language just became more type safely. And one of the coolest features of modern C++, in my opinion, is general purpose smart pointers. Those things, if I, like allocate some memory and I assign it to a smart pointer, and I, like pass that pointer to another method, to another function inside my C++ code, at some time that pointer will go out of scope. And typically, and in my application, I'm going to show that later in the remainder of the samples, if I'm allocating memory and if I forget to release that memory, then I have a potential problem because I'm leaking memory. Using smart pointers inside C++, that's not going to happen anymore. The C++ compiler is smart enough to realize, like, hey, Here, this pointer goes out of scope, so what I can do is call a delete operator automatically without the developer having to worry about it. Now keep in mind that's not garbage collection, what you would be familiar with when developing managed applications. It is something different, but it's still, like a validity check that, hey, the chance of me leaking memory in modern C++ is very, very small. And that's actually, that's a really cool feature, I think. So we've talked about C++, we've talked about modern C++, we've talked about, Windows 3.11 with an old version of C++. But why would I want to use C++ on Windows Phone? I already said, platform independence might be something that is really important. So portability of code, because that's basically what you're saying if you want to talk about platform independence, that's a very important reason why you should consider C++ for parts of applications. Reusing code can be another one, and that's the scenario that we're going to use during the demonstration. So I have that old code, I want to reuse that in a modern platform, and I want to see if I can play with that. Funny enough, when I started preparing this presentation, my initial thought was performance is the most important reason to move to C++. But if you look at modern C# compilers with modern JIT compilers, again, functionality that we are borrowing from Windows, then you can see that performance is kind of less of an issue. It's way more important to use C++ in order to achieve portability and in order to achieve reusing of code. And C++ is already used, extensively on Windows Phone. And here are just a few examples. I'm not going to cover Unity. I'm going to cover SQLite a little bit. But Unity is a cross-platform game engine. It is entirely written in C and C++. And with Windows Phone 7, Unity already existed. It was a game engine, to develop games that could target web games or Android or iPhone or something. And we could not use that same game engine inside Windows Phone 7 because we didn't have native support inside Windows Phone 7. Now, when we moved to Windows Phone 8 and made use of the Windows 8 runtime, all of a sudden we kind of got for free also native support. So also the possibility to make use of a product like Unity for game development. So that library itself is written in C++ and it exposes functionality in either C# or JavaScript or Bool to the outside world for programmers to actually, create games. So you develop your gaming engine inside Unity, and the presentation, you're using one of these other options, for particular phone devices, for instance. SQLite is a similar story. SQLite is a library containing a database. That database is written in C++. And more you will see that SQLite is used cross-platform. So, it's used on Windows Phone 8 right now, on Windows 8, on Android, on other devices. And once you have a database, you can easily take that database and use the database engine to, access data on, for instance, a Windows Phone. And in one of my samples, I'm going to show you a desktop database that makes use of SQLite and how I can easily access that. So using or making use of native libraries can be a very important reason to make use of C++. However, there is a catch, because it's not possible to use C++, to use native code in combination with a managed application, an application written in C# in combination with XAML. It's not possible to use that C++ libraries directly. So there needs to be an intermediate layer that kind of translate native C++ data types to something that Windows Phone understands being Windows Phone runtime data types. And from there, through language projection, understands C# data types. Because if we're talking about cross-platform development and cross-language development, the only thing that always matters is how are data types defined and how is data being passed through the system. For instance, in traditional C, a string is a collection of characters terminated by a null character. In C#, a string is an object. That object allocates some memory somewhere. It definitely has not single characters because it's making use of an ANSI coding, so it already has word characters. And a termination character is probably not a null character or something. Now, in order to understand, on one hand, C strings and on the other hand C# string objects, you need to have some translation. And it's just great if the translation can be done automatically for you. And that's why we need a layer in between, a middle layer, in order to, like make use of translating one data type to another data type. And if you're just a managed developer, like for a long, long time, you're kind of familiar with that because we had a similar mechanism when we were using or developing .NET applications. If you had a .NET application and there was this cool Win32 API that you desperately needed but was not exposed in the .NET framework, what you always could do was p-invoking back to native code. And the trick there was you needed to marshal your data. The data types needed to match somehow. And there's something that sometimes you need some manual operation there. So for a large time, let's see how we're doing with time. Okay, we're still doing fine here. For, like quite some time I'm going to spend now by taking that original prime numbers library and bringing that to Windows Phone, and let's see if we can, like use that inside an application. And again, for the sake of the demonstration, the code is really simple. I did that deliberate because I don't think that, like complexity will add any value to this particular presentation. It's more like the mechanisms that you need to choose in order to make use of native components. That's way more important. And by simple examples, hopefully we can concentrate on the things that really matter here. So what I'm going to do is I'm going to just, like start another instance of Visual Studio. And I prepared a little bit for this application. So let's go to the prime numbers project here. I'm going to start it. I'm going to talk you through it. And let's see what's going on here. So I have a little application called prime numbers. And I have that same math library that I showed you when it was running on Windows 3.11. It has two methods, or two functions even, a prime numbers and an isPrime. IsPrime simply takes a number and returns a boolean. It's either a prime number or it's not. And prime numbers takes a range from its starting value to a stopping value and returns an array of integers. Because at that time I thought like, hey, like 20 years ago, it's kind of cool. I know how to manipulate pointers and I can make use of that. However, if you take a look at my implementation, there is a particular issue with this code. But it's 20 years ago. This was perfectly safe at that time. Today I would get sleepless nights about it. But what I'm doing is like, hey, I'm allocating an array of integers. I'm taking a nice large value because I know if I'm, like determining if numbers are prime numbers and I have a range of 10 numbers, the actual number of prime numbers is going to be less than 10. So I allocate 10, like integers there to be on the safe side. I'm going to pass the result in that array, and then I'm also going to specify, and that's just my determination, that, hey, in the first element of that array, I'm going to tell the caller how many prime numbers I found. Then I'm going to do some magic calculating stuff that probably nobody, like, doesn't matter if you don't understand it, but this is the real magic that I needed. Actually, what it is just a stupid delay. I'm just, like simulating that this calculation is taking a long time. And I need that for the rest of my demonstration. Then I'm going to return my result. Now, there's a big issue here because I allocated memory. And I kind of, like didn't write any documentation, but I'm expecting my caller that they know that they should free up that memory. So if I would run this on a phone and without documentation and people are starting it over and over and over again to calculate prime numbers, at some time I might run into a low memory situation because I did not free up that memory that I allocated. That's something I need to fix. But it's exactly the same code that I just took from that Windows 3.11 thing. So I wrote a little user interface around it. And here's my UI. It's very simple. I have a beginning value in a text box. I have an end value in a text box. I have a button. And each time I hit that button, the idea is that I'm just going to, like calculate a range of prime numbers. So let's just run it. Let's see what's going to happen. Here's our good old emulator. And of course, if I'm clicking here on this prime numbers, there's nothing happening because I don't have functionality there. Oh, and I did another thing, and that's why I needed a delay. I have a button is responsive. Each time I'm clicking this button, I'm incrementing a counter, and that counter is data bound to another text block. That's the scenario. So what I'm going to do now is provide code in order to calculate a range of prime numbers. And those prime numbers will be displayed here in this area. Now, initially, what you might think is like, hey, you have a C++ library, a math library. So the typical thing to do inside a XAML-based application is add a reference. Because each time we want to use some functionality, we just add a reference. So I'm just right-clicking here. All my references, well, once I stopped debugging. I'm going to add a reference inside my solution because I want to add a reference to this math lib. That would be an initial thought that you might have. I'm going to click OK. And what you will see is like, hey, oops, I get an error message. So a native library cannot immediately be referenced inside a managed application. I need something in between. I need a middle person, a middle man that is capable of translating data types from one world to data types in another world. So let me just create that middle layer here. And that middle layer, if I'm just going to, like go to my solutions here, I'm going to add a new project. And that middle layer is a Windows Phone runtime component. And effectively, a Windows Phone runtime component is an extension to the APIs that we expose in the Windows Phone runtime, and in the Windows runtime if you wish. So I'm extending functionality of the operating system. I love that Windows Phone runtime component one name. And what I get is a native library, but that native library is a little bit different from that pure C++ library I created. Because this library makes use of C++, but also understands our Windows Phone runtime data types. And what I want to do right now is the following. I'm going to add a namespace here because I need some functionality. And that functionality, let me just add using there, that makes a lot of sense. Using namespace platform. I need to make use of functionality that is available inside the Windows Phone runtime platform. And what I want to create is a method. And that method should return a string, because if you remember my user interface, I kind of, like said that I have a number of text boxes. Well, text boxes have a text property in Windows Phone. So returning a string and assigning that to a text property kind of makes sense. But I'm not just using, or I'm not returning any string or something, but I'm going to specify that, hey, this string is a native Windows Phone runtime data type. And I specify that by terminating that string type with a head. This indicates that I'm using a Windows Phone runtime component data type being a string head type. And what do I want to do? I want to get prime numbers. I have a start value and probably an end value. And that's basically the declaration of my method that I just want to get an implementation for. So I'm just going to copy this, go to my implementation here. There we go. Reformat it a little bit. And since this is part of my Windows Phone runtime component class, I need to specify that this method is living inside that class. And what I now can do is call from inside this Windows Phone runtime component, I have the possibility to call native library functions. So what I now can do is add a header file here. And that header file is in my math library, the mathlib.h. Adding this header file means that now I can take an auto variable in modern C++. I can have a native result, and that native result should call the method prime numbers that is now known and which lives inside that math library. So I'm just passing my parameters, start and end. But I need to return a string head type. string head is that Windows Phone runtime, or is that Windows runtime data type that I want to return. So first I'm going to allocate a variable or declare a variable of type string head. I'm going to call that result. Then at some time, since I studied my source code, that I need to free up that memory from that native pointer there, because that's not a smart pointer in this situation. So I'm going to delete my native result. And I'm going to return my real result. And in the meantime, what I need to do is convert each time something from that array of integers to a string value. And I just have this little code snippet here in order to not type too much for you, because that would just be boring. So I'm taking that knowledge that, hey, the number of prime numbers is listed in that native result, and I'm just whiling and just concatenating to that string type. So let me compile this. Let's see what's going on. And we see immediately an error message, because I added my header file, but I did not add the library to the linker, so I get an unresolved external right now. So what I'm going to do here in my project properties is I'm going to specify inside my linker that I want to have additional input libraries. And one of those libraries is living under my debug folder, under a mathlib folder, and it's called mathlib.lib. Let's do OK. Let's try this again. OK, cool. So now I at least have built my Windows Phone runtime component. That component linked my math library, my old C++ code in. And what I now can do, since a Windows Phone runtime component knows about managed applications written in C# in combination with XAML, so now I can add a reference. That reference is again in my solution, but it's now the Windows Phone runtime component that I created. I'm going to add a reference to that. I'm going to go back to my main page here. I have this prime number thing. If I take a look at my events here, then on click I have an event handler. So what I'm going to do is take a look at that particular event handler and add some functionality there. So here we go. Here is that find primes thing. And what I now can do is take a var data type. The name is Windows Phone runtime component. And I'm going to create a new instance of my Windows Phone runtime component. And in that is a class called Windows Phone runtime component. So I just created that instance here. And I can now assign a text property inside my result text box to my Windows Phone runtime component, its method, called getPrimeNumbers. And I need to feed it with a start and an end time, and they are, or with a start and an end value, and they are available too in two strings inside text boxes. So I'm going to convert those to integers. There we go. And I'm do the same thing for the end value. And hopefully we are good to go now. Looks good, so I'm going to execute this on my emulator. And let's see what's going to happen. So I'm going to hit prime numbers, and you should see feedback whenever I'm touching my emulator. So we're going to go prime numbers. And I'm clicking responsive continuously. And you see that that's kind of a bad experience. It's definitely not fast and fluid, because for the whole time that I was, like doing my prime number calculation, the user interface of my application was kind of frozen. And that's definitely not the behavior we want to have. I can show that again by just doing this again. You will see that that button stays red right now until the calculation is done. And only then I have my user interface responsiveness back again. So this is something we're going to fix in a later stage. For now, I'm going to show you another more, enterprise-related line of business software-related sample. And we're going to come back to this sample in, like a few minutes again. Because another thing is what I told you before is that, hey, you can make use of SQLite. And let's just take that approach. So I'm going to open another solution. And inside this solution, what I want to have is a database. That database is already available, so I'm going to add an existing component here, or an existing module, an existing item. And that item is this database. It's a MediaMonkey database, and MediaMonkey is, like a third-party product that is, making use of a SQL database to store information about CDs and DVDs and stuff like that. And I'm using this at home. So this is a database that is in size something like 70 megabyte. It's a real database. I just took it from my desktop, flew to Barcelona, and now I'm going to incorporate that inside a Windows Phone application. So I'm going to add that database. I'm going to specify here that, hey, this is content. It should not be compiled, but I want to have it copied to my phone. And what I now want to do is make use of SQLite functionality. And SQLite is available as a Visual Studio extension. So if I'm taking a look at extensions, what you can do is install a SQLite for Windows Phone. SQLite for Windows Phone is an in-process database. It's written in C++, so it's a native component. I already have it available because I installed it already. So what I can do right now is take a reference and add a reference to a Windows Phone extension being SQLite. So now I have the functionality for SQLite available inside my solution, but again, similar to my math library, this code is written in C++. I cannot directly access it. I need a layer around it. And that layer around it was kind of lacking so far. There was something on Codeplex, but Peter Thor, one of our great developers, Windows Phone developers, created a wrapper that has the capability of accessing SQLite and retrieving SQLite data. So I'm going to add that project that he created. He created it as a project, just as a download from Codeplex. And it is called SQL WinRT. And in fact, he created two different projects, one for Windows Phone and one for Windows 8. And they are exactly identical. So the code we are using ourselves to retrieve data from a database can be shared completely between Windows 8 and Windows Phone without having to touch any byte there. So I'm just going to add that piece of functionality. Yes, it's completely safe. And this is again a Windows Phone runtime component. And if it has full source code, so I can take a look here. For instance, inside my database, what I can do is open a database, I can close a database, and Peter wrote this functionality in such a way that it has asynchronous support. So if an operation takes longer than 15 milliseconds, by good practices for a Windows and Windows Phone application, you need to have those long-lasting or longer-lasting operations. You need to execute them asynchronously on a separate thread to keep a user interface fluid and fast. And he wrote that entirely in that way. So now if I'm going back to my original solution, I can add a reference from my solution to that SQL WinRT phone project. I'm going to quickly recompile. I'm going to take a look at my user interface and see how I'm using this, this code actually. And what I'm doing, and this is again bad practicing because it's just a sample. You should never do this in a loaded event of my application starting or my page being loaded. But what I'm doing is I'm going to, create a list of albums, a list of CDs, let's say. I'm going to get a reference to my database. Then I'm going to open a SQLite instance on that database. And I'm just going to query all albums inside that database. I'm just going to select all artists and album information from there. And I'm data binding that to my user interface. Now, in order to get a little bit of response, The first time I'm only retrieving 100 records, and then I'm going to delay load the rest of my database, because that database contains something like 60,000 entries or something. So if I'm running this, that's interesting. Then something is already in use by another application. Which makes sense because I can only debug one instance at a time. Oh well. So if I'm running this, hopefully, what you will see is after a little bit, because 100 records is still much, I get a long list selector with record information from that database. It's just nicely retrieved. And I have a responsive user interface because all those commands inside that database are executing in a asynchronous way, but in the background I'm still loading. And what you will see if I can talk long enough is that all of a sudden this is going to change because I'm going to refresh with more data coming from that database, and then I have the full information available there from that database. A better approach would have been to just, like increase the amount of data gradually and just add it while, like more records become available. But what we will see is after a while, I get all my data available. And now if I scroll through it, we probably have, 60,000 different entries here. And what surprises me, and that's one of those great, cool possibilities of using existing native code, is if you look the speed with which this is happening, that's just simply amazing. And the ease of retrieving data from a database, it was like 4 statements for myself. So reusing functionality makes a lot of sense because as a programmer, I become way more productive. Having said that, let's go back to the slide deck before we're going to add some additional functionality to that original sample I had. Because I need to talk a little bit about Windows Phone APIs to make exactly clear why I needed that Windows Phone runtime component in between. And this, to be honest, especially at the end of the day, is not the lightest, not the best, and not the coolest topic to talk about. Because Windows 8 supports a lot of different APIs. And it's kind of hard sometimes to choose, and it's kind of hard to explain why those different APIs are available. And you're confronted with choices. Now, if you're a managed application developer, you probably are familiar with the .NET framework. So if you develop a XAML-based application for Windows Phone 8, you can use C# and you can use familiar .NET APIs in order to get functionality from the operating system. But side by side, there lives another API inside that same platform. That's the WinPRT API, the Windows Phone Runtime API. And the .NET API is kind of projected to functionality of the Windows Phone Runtime API. So if there's some marshalling, if there's some parameter translation necessary, Microsoft takes responsibility of translating .NET types to WinPRT types. And the mechanism through which that works is language projection. If you are a native application developer, you're typically going to use C runtime APIs. And in my math library, I used a few of those. But you also have access to WinPRT types, data types, and APIs. So you can also make use of the Windows Phone runtime. And if you're a game developer, you can use Direct3D and or DirectX, which is yet another API. So you have a lot of different choices for developing applications and talking to APIs in a Windows Phone operating system. Now, in the beginning, when I, realized that, it was kind of like, wow, that's scary. That's, what am I going to choose? What should I choose there? I don't know. Do I still want to develop applications for Windows Phone? But then I started thinking, and it's like, hey, calm down, Martin. It's not as bad as you think it is. You're running a long time along in this industry. If you managed to do C++ development 20 years ago, then how hard can it be to develop a Windows Phone application, right? And that's kind of true. Because those differences are, they are not that relevant. If you feel comfortable talking to .NET APIs, just make use of .NET APIs. And we take care of translating that to Windows Phone Runtime APIs. So if you're a managed developer, go ahead and use Windows Phone Runtime, or go ahead and use .NET APIs. You can write your applications in XAML in combination with C# and Visual Basic .NET and just feel comfortable with that. If you're a game developer, well, then you are, like moving more to native APIs. Maybe you need to invest a little bit in learning about Windows Phone runtime APIs. So what is important is use an API that you feel comfortable with. If you are, on the other hand, considering reusing native code, then all of a sudden the choice of API becomes somehow important for you, because in that particular case you need to develop a Windows Phone runtime component, and that Windows Phone runtime component will make use of the WinPRT APIs. So inter-language solutions, if you're like targeting that, then you need to be aware of WinPRT APIs, and you need to learn about those. Now that's not a bad investment actually. The Windows Phone runtime APIs are like similar and in many cases identical to the Windows runtime APIs, and that's the new API that like starting with Windows 8 will evolve and will be used more and more and will be extended more and more. So it's a good investment to understand that. If you're using .NET APIs, no worries. Language projection binds your data types to WinPRT data types that the operating system understands. This is basically the same thing that I was saying already. Take the API that you're comfortable with. I just wrote it down a little bit more extensive inside the slide deck, like mainly just for reference. But make sure that you are not, like forgetting everything if you're a .NET developer. Just stay with those things that you're comfortable with and, like develop the best applications possible. That's the idea. If you see those APIs in action, what you will see is that a .NET API typically starts with the namespace system, and then, for instance, IO.isolated storage. A Windows Phone runtime API, the WinPRT API, typically starts with Windows followed by something, Windows storage. What you also will see if you have the Windows Phone runtime APIs, if you're going to make use of them, methods inside those APIs very often end with an async postfix. So create file async, read file async. In .NET APIs, you don't necessarily see that. But don't worry, if we, if you call a .NET API to do some file I/O, it will be translated to an asynchronous version of the Windows Phone runtime API without you having to worry about it and without you having, you don't even need to worry about exception handling or something. Because of the fact that we are using an async pattern and develop our applications kind of in a synchronous paradigm, but they are running multi-threaded, it also means that, you can just use exception handling as if you were a synchronous application developer. Now, what I've been talking about is a math library written in C++ 20 years ago, and I used some new Windows Phone runtime component to actually get that native old component running inside a modern Windows Phone application. And there are some design considerations that you need to be aware of if you want to take that same approach for using legacy code. You should probably look at that Windows Phone runtime component that I created just as a wrapper around a native component. Don't give it additional functionality. Just take that one single library to access functionality inside the native component and to, pass data back and forth. So, in other words, your Windows Phone runtime component kind of has two interfaces. On the upper side, it does communicate with your Windows Phone application. And in order to do that properly, what you want to pass is Windows Phone runtime data types. At the same time, your application, if it's written in a .NET language like C# or something, will use .NET data types, and we take care of converting Windows Phone runtime data types to .NET data types in a mechanism called language projection. On the lower side, your Windows Phone runtime component has an interface as well to your native library. If you're calling from a Windows Phone runtime component to your native library, what you need to use is native data types that are known to C and C++. And any translation will happen in between. Since your Windows Phone runtime component needs to be written anyway, I can now add a little trick to make my application behave a little better. And that's something that I want to show you, because what I can do inside my Windows Phone runtime component is make functionality, make method calls asynchronous, even when the underlying code is synchronous. And that's something that, you know, like, I think this is key of making use of native functionality inside a Windows Phone application. Because 20 years ago, to be honest, when I wrote my math library, well, I was a young developer at that time, but I did not really have a clue about multi-threading, and it was all difficult and blah, blah, blah. And I was running on MS-DOS. I mean, what do you mean multi-threading? We hardly had that concept, you know, like in place at that time. So I didn't worry about it. And my application just, you know, like took a long time to execute. And each time my boss was asking, like, why does it take so long? My answer was like, well, yeah, hey, it's kind of difficult stuff that I'm doing, you know, like, let's not get into details, it's all hard and blah, 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 and let me just take care of it. And of course, you know, like, I resigned, and they're still using that same code at that company I worked for at that time. And now, today, you're gonna be scared to actually, you know, like, touch that code. Because if you touch, you know, like, legacy code that is still working, but nobody really knows why it's still working, well, you know that if you even open it with an editor, that probably you're doomed, and it's, you know, like, gonna break each and every time you're gonna do something else. So if you want to change the behavior of that piece of code, it's way better to try and change that behavior in a component that you completely understand and have full control of. And that will be that Windows Phone runtime component. Another thing that you're gonna run into, and I'm gonna, you know, like, combine both things to actually show some more code right now, is if you want to debug native code. Debugging native code is completely similar to debugging managed code. But we're using a different debugger. Because one debugger must understand machine language, so the code compiled for an x86 or for an ARM processor, and a managed debugger must understand intermediate language before it's just-in-time compiled. So they just understand different types of code. But from a functional point of view, a debugger is a debugger. A debugger should have a capability to set breakpoints, to inspect variables, to set new values to variables, to skip code, and all that kind of good stuff. Both debuggers, a native and a managed debugger, are available inside Visual Studio 2012 for Windows Phone in that Express edition. There's only one catch: you cannot use them at the same time. So you either need to choose for a managed debugger or for a native debugger. And that's kind of hard. I mean, what am I going to choose for? And typically what I'm doing, if I'm debugging native code, I'm not immediately setting breakpoints on native code. Because I'm still, you know, like, I want to be in control, I want to understand what I'm doing. So what I'm still first doing is, you know, like, make use of the managed debugger, maybe on an event handler set a breakpoint, then I'm just going to single step, you know, like, over my code. At some time I'm going to hit a native method call, I'm going to step over it, I'm going to check return values. If they're suspect, then I know, like, hey, this is a location where probably I need to dig deeper and need to get into native code. Then I'm going to change to the native debugger. I'm going to continue working there. So roughly I'm going to find a piece of suspect code, and then I'm going to fine tune. And in that process, I'm going to change debuggers because I simply cannot use those debuggers side by side. So let's take a look in action what that looks like in our last demo of the day. I still have that. I still have a mouse, cool. So I'm going to get rid of this database sample. That's history right now. Because what we noticed in our scenario, we're going to go back to the math library and prime numbers. And one of the things that we noticed was, hey, somehow the performance of that math library was pretty bad. So if I'm retrieving prime numbers, I have some pretty bad behavior there. So I'm going to set a breakpoint there. And that's kind of misleading because that breakpoint shows up perfectly here. So I'm going to run my application again. There we go, cool. I'm going to hit prime numbers. It's not much happening, and definitely not a breakpoint that is hitting. And what you see is that, hey, I get the end result. What you also see is that my breakpoint seemingly is disabled right now. And I didn't do anything. So the reason for that is that default, when I just open a solution, the default situation is that we have the managed debugger active. And now you need to be aware where you need to set that, because in this sample, I have, like a solution with 3 different projects. The debugger cares about that particular project that owns the user interface thread. And that's typically my application right now. So that's this prime numbers thing. If I go to properties here in my Windows Phone application, and if I go to debug, let's stop here, that's probably better. If I go to debug, I can choose for my UI task to debug managed code, or I can choose to debug native code. Now if I'm starting again, what's going to happen this time is that if I'm hitting this prime number thing, you see now I am running the native debugger. I stop there, and I can inspect everything that's going on here. So one of the things is like, hey, I got a start parameter of 0, a stop parameter of 100. I can inspect those variables. I also can see on my call stack that I'm coming from a Windows Phone runtime component. Well, that's exactly correct. Even though it's a different project inside my solution, this component was responsible of calling that native code. But this component's getPrimeNumbers method, on the other hand, was called by some managed code. And there you see that those 2 debuggers, the managed and the native, don't really nicely work together, because what you will see here, a native debugger works that it inspects the stack, because parameters are passed through the stack and stuff like that. So it doesn't recognize managed code. What it does recognize here is something called agcore.dll. Well, this is a managed component responsible for maintaining a piece of the user interface. So probably that's where I click the button, but the native debugger can only look at the stack and say like, hey, this and this and this address I found, it doesn't nicely find my click event handler. In order to find that, I need to switch back to the managed debugger. But for the rest, this thing can, like entirely properly do everything you are, like expecting from a debugger. So let me just run until here. I can run until cursor, for instance. And you already see like, hey, that's taking some time until I'm there. So probably the code in between this area is kind of suspect for taking a long time. That's my determination right now. And I want to change that. Now, of course, if I would still be that 20 years younger developer from 1993 or something, I would probably just remove this while loop here because it doesn't make any sense. But right now, being a modern developer, I'm going to think like, well, there must have been a reason why this piece of code is in there. And I better not break it and show it to my boss because, like, I don't know what's going to happen, but terrible things are probably going to happen. And again, this is a simple example. This could have been very, very complex code, right? Now, instead, I have the full power to work on this Windows Phone runtime component. And I also know that the Windows Phone runtime, all those APIs work asynchronously. So what if I could make my Windows Phone runtime method get prime numbers? If I somehow can get that into an asynchronous method, would I get better? Would I be better off? Well, let's try that. I'm going to go to my header file first. I definitely want to keep this functionality, but instead of having this a public method, get prime numbers, I'm going to make that into a private method. I'm also going to add another namespace because I want to make use of asynchronous functionality. And that asynchronous functionality is exposed through the Windows Foundation namespace. Now, instead of returning a string, I'm going to return another data type, and I'm going to say that my method is going to be asynchronous. Just by convention, a method that is asynchronous ends with the postfix async. And what I'm going to do here is I'm going to return something of an interface called asynchronous operation. And that async operation in itself is a template, and it's going to return something of type string head. And async operation, again, is a WinPRT type, so I'm going to end it with a head. Now, the next thing I'm going to do is just copy this declaration and create an implementation for it. So I'm just copying it here, make sure that it's formatted properly. Make sure that that method belongs to this class. There we go. Cool. And do something like this. Now what I would like to do is, in an asynchronous manner, kind of just return magically something like get prime numbers. And hopefully running it on a separate thread. If I could achieve that, then I'm done. So I'm going to pass the same parameters, and I'm going to compile. And unfortunately, and of course IntelliSense is already telling me that, like, hey, what you're trying to do, you want to return something with an asynchronous behavior, but instead you're returning something with a string head data type. That's not going to work. So I need more functionality. And what I'm going to add is something from the parallel task library. I'm going to include another header file for that. And this library, this piece of functionality, contains asynchronous behavior. I'm going to add another namespace. If I can type to this. Okay, there we go. And what I'm now going to do is the following. Instead of returning prime numbers, I'm going to return something that creates an asynchronous operation. And if you take a look at IntelliSense, what it expects, and I know this is going very fast, but it expects kind of a function pointer to something. A function pointer to something that sounds like, you know, like a lambda expression. And in C++, you can create lambda expressions as well, because they are basically pointers to functions. But they are pointers to inline functions. So inline, I can define what kind of functionality I want to execute. And lambdas in C++ are kind of weird, because they follow a weird syntax, because they need some weird keys on your keyboard. But if you have those keys, like those square braces, followed by braces, followed by curly braces, then you basically have the syntax of a lambda expression in C++. Now the only thing we need here is that they need some meaning, because this really looks weird. This first thing in those squared braces, it is an information, it needs to inform the compiler how we're going to treat the parameters that were passed to this function get prime numbers async. And I have two options there. I can pass them by value or by reference. For simple integers, I'm going to pass them by value. And what that means is that I'm going to pass them over the stack. And I specify that by giving this equal symbol. In C#, if you're using a lambda, you don't have to do that, because the compiler can figure it out. The C++ compiler cannot figure that out. Those braces here can be used to specify additional parameters that are only valid in the scope of the lambda. And then finally, between the curly braces, I can put my functionality. And I need a semicolon there. Now, my functionality in this situation is simple. It's just going to be this. I'm going to copy that there, making sure I'm deleting it here. And there we go. I'm going to compile. And I get an error. But that kind of makes sense that I'm getting an error here. Because if you look here, I'm calling get prime numbers. But I kind of demoted get prime numbers to become a private method inside my Windows Phone runtime component. And instead I made a public new method being get prime numbers async. So I need to touch this code as well by calling this async method. But this in itself doesn't make a lot of sense because I don't get, like the right data type here. But what I need to do is I need to wait for the result. So I'm going to await for the prime number method to return with some meaningful value. And then I'm going to continue executing. And in order to make use of asynchronous functionality, I need to sign my, if I want to call it like that, my method with the async keyword. Now if I'm going to compile, then at least it compiles. And 20 years ago, if it compiles, I would have said to my boss, like, hey, I'm done. Bye-bye. I'm going to go on holiday. Now this time, especially since we are, like here for 70 minutes already, I'm not going to do that, but I'm going to show you actually that this is going to work. Which, I mean, for me might be great because I can show you that I get some working code. For you, it's probably pretty bad because you need to wait longer for your phone, or your potential phone, I should say. But let's just take a look if this is working right now. So I'm going to run this again. I'm going to hit prime numbers and see me hitting that responsive thing as well. Prime numbers. Oh God, there's a breakpoint set. At the highlight of the demo, it's not, this is awesome but bad. Why is it? Yesterday night before the mirror, I was rehearsing in the hotel room. This didn't happen to me. Why does it happen right now? Because now, I mean, I could do that, but I just hit that, so that's not fun. I'm just going to wait a little bit. Okay, cool. Now I'm going to do it again, though. I've got to terminate this application because I want to have it from scratch. It is working more times, but I really want to have this from scratch. So here we go. Prime numbers, hit, boom, 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 boom. I have a responsive UI, and there are my prime numbers. And I did not touch my original math library. That's the whole idea here. Now, of course, I'm still waiting for that result there, but in the meantime, the user can do something else. The user would not complain right now about this application because they have the possibility to do other things. If I would have left it as a synchronous method with that long second or so delay, they would be really unhappy with that legacy code. So taking the possibilities, the functionality that we expose through Windows Phone runtimes and bringing that in combination with, like native code is a very, very, very powerful mechanism. Key takeaways for this session. All Windows Phone 8 applications can use C++. You can use any legacy code you want to. You have to be careful though, if I'm saying you can use any legacy code you want to, what you need to comply to is, for instance, the standard C library. If you're calling Win32 APIs inside legacy code that's doing nasty things with threads or with memory management or something, those types of applications or those types of libraries will fail to compile. Because even though this is native code, it is still running in a protected environment inside your phone. So it's not that using native code that you can party inside the phone and access all the memory that's available or something. We restrict you to certain parts. But a math library, or for instance, an image manipulation library, codecs for, like sound conversions, stuff like that, perfect candidates for using native code. Complex financial calculations, similar story, because you don't need Win32 APIs for that. So most important, C++ enables portability and code reuse. And the Windows Phone runtime is your key, that's your best friend. That's where you translate native data types to .NET data types, to Win Phone runtime data types, and where you also can add asynchronous behavior to your applications. There's a lot of other breakout sessions, not on Wednesday anymore, but tomorrow there's some good stuff. If you want to know more about SQLite, I showed a very little example. I would strongly recommend you to go to Andy Wickley's session 8:30 on Friday, because he's really going to dig into it. He might even talk about synchronization of data and stuff like that. There's, like lots of other cool sessions. We have hands-on labs. You've all seen that, so why are we worrying about that? But please, if there are additional questions, I'm coming in a second to you. Make sure that, like you visit the Windows Phone booth, and we're going to try and do everything to help to answer your questions. We have sessions tomorrow and Friday in the theater as well. There's a number of resources. Well, actually, there's only one resource you need, like at a conference like TechEd, www.windowsphone.com/business. that's your one-stop shop to get all information for, like using Windows Phone in a business environment. There's a lot of resources, and please evaluate this session. If you liked it, please let me know. If you don't like it, please let me know as well. I would love next year to be at TechEd again, but if it's a waste of your time, I should not have the right to appear here. On the other side, if you think like, hey, we want to know more about this native code and blah, 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 or other weird things, then please let me know and evaluate that session.